my final related rates problem, I'm going to take a look at number 5. This is number 5 in section 4.9. This is on page 177 in the Foerster book. And this is the baseball problem. We've got this guy hitting a line drive. Shows you a graph of what's happening here. Specifically, you have a right triangle being created with the distance between the base runner and home plate, and that's specifically what I'm going to be looking at here. We are told that bases on a baseball diamond are 90 feet apart, if you didn't know that, and we're told that he's running at 20 feet per second. I want to know how fast his distance is changing when he's halfway to third. Okay, so the first thing I'm going to look at here, I'm going to label my diagram a little bit. First of all, the distance between bases doesn't change, okay, and really important to put in any constant value that you know right off the bat. So that's 90 feet. I'm looking at his distance from third base, specifically. I'm going to call his distance from third base, I'm going to call that A. So basically I have an A value here, I have a B value, and I'm going to call the distance from home plate the C value. So we want to know how fast his distance from home plate is changing. Well, I've labeled that as a C. The change in his distance from home plate over time is dc dt. That's what I'm looking for. Okay, I am given that he's running at 20 feet per second. Okay, his distance between his current position and third base is changing at 20 feet per second. Notice that that side is getting shorter. That's the change in A with respect to time. That's negative 20 feet per second. And really, this is a Pythagorean theorem setup. Basically, I know that A squared plus B squared is equal to C squared. In this case, B really is a constant value. The distance between those bases is not changing. So I can do A squared plus 90 squared. Sorry about that. A squared plus 90 squared is equal to C squared. And I can go ahead and find the derivative here with respect to time. It's going to be 2a dA dt plus 0. Okay, the derivative of 8100 here is a constant value. That's just going to be 0. And that's equal to the derivative on the other side. That's 2c dc dt. Now, always go back and check and see the information you have matches up with the original problem. Notice there that I have a dc dt that I'm looking for. I have a dA dt that I was given in the original problem. And notice that my equation involves those values. Okay? Now, I can divide both sides by 2, and that's going to cancel out the 2's. So I have A dA dt equals C dc dt. And if you go back and you look at the original problem, you can see that it's asking me, among other things, and what I'm going to focus on here is I want to find how fast his distance is changing when he's halfway to third. Okay, that's his distance from home plate when he's halfway to third. Well, when he's halfway to third, I have to have that A value to fill in there. It's going to be 45 feet. Okay, he's 45 feet from there. So that's my A value. I know that he's moving at basically negative 20 feet per second. So that's my dA dt. That's negative 20. And I'm looking for that dc dt value. Now, I'm going to have to find C. Well, notice I have a right triangle which at the moment has a side length of 45 and a side length of 90. So I'm going to take that and substitute it into the Pythagorean theorem. I'm going to have 45 squared plus 90 squared is equal to C squared. That's equal to 10,125 equals C squared. And that is not a whole number. That is not a whole number square root. So I can either simplify, I can do various things here. I could try to simplify that. For example, 25 does divide out of that 405 times. I could write that as 4 radical 405. I think for the time being, I'm actually going to write it just as the square root of 10,125. And so that's what's going to be substituted in for my C value here. And anyway, I should be able to solve now. I'm going to end up taking 45 times that negative 20. That is negative 900. That is equal to this radical 10,125 times dc dt. I can divide both sides by that value. And when I do that, I'm going to end up getting a value of dc dt that is approximately equal to negative 0.8944. Now, what is that? That's a change in distance from home plate. Okay, change in distance, that's a change in C. C is measured in feet, so that's feet. Change in time, of course, is in seconds. And that is my dc dt value.